Hello and welcome everyone to today's episode. Today we are going to be covering the following topics. All the timestamps are in the description below. And I hope you enjoy today's episode. So let's get started on these topics. What boxing and unboxing means. Let's have a look at with this example and also learn about array lists and lists. So here, as you can see, I have an array list data type, and this is the variable name, and I'm just creating a blank array list using the new keyword. Here I have an integer being declared, and that holds the value 10. Now, when you add an item to this list, so that's the variable name, and I'm adding the variable num into this list, what happens is, since int is a value type, so here this is a value type and it's stored on the stack. Stack is, think of it as easy to access memory within the computer, and it's faster, and you can store intrinsic types or native types very quickly on it, while objects are stored on the heap. So here, since array list over here is of type object or accepts anything, so you can add numbers, text, or classes and so on, it stores it on a memory called the heap. So what happens is when you have this value over here being added to the array list, it converts it and puts it in a box like this, puts it in a box and then stores it on the heap. And this is because not only can you add integers in here, you can add other things such as text. So if I do this, and you can see I can add the word hello, and you can see the compiler has not complained and it says it's fine. There are no issues with this. This is because it boxes everything. So it boxes this number and it boxes the word hello and stores it on the heap rather than the stack. Heap, think of it as like over here, and stack, although it's smaller, it's over here. And how stack is spread is you've got different places like this on a stack, while heap is stored like this, and you've got various different objects. So you can have objects of different sizes and so on. So it can pretty much store anything. And here you can see when you have to then convert that back into an integer, you have to use a technique called unboxing. So it means converting the object data type back into an integer. And this is what causes more processing to happen. While here, so that's what is called an array list. But if you use a list here, list accepts generic data types. So basically it lets you use generics to say actually exactly what data you want. So in this instance, we've gone this list 2 needs to contain integer lists only. So here again, we're adding the value 10, and then you see when we convert it back, there is no longer any need to do this conversion. So you don't need to do this over here, and you basically assign the value to an integer without converting. And here, as you can see, when I try and add the word hello, I get an error. Whereas here, I didn't get an error because array list accepts any data type. So that's why it's stored on the heap as an object, while list over here is not stored as an object. It actually stores the integer values. So here you can see the error we are getting cannot convert from string to int. This is because we only accept integers here. So if I run this program, and as you can see, we get the value in both, but this is more expensive because you have to convert an object back into an integer, while with a list using generics and int, you don't need to do the conversion and it is faster. How do you resize an array in C#? I have an array here of strings. It's called fruits and has the following values in it. And here on this line, I'm just printing out the third value because arrays are 0 index base. So this will be index 0, 1, 2. So mango is at position 2 or index 2. The traditional way of creating or resizing the array is by declaring a new array here of the same type as we had before up here, and then basically increasing its length by 1 or whatever number that you want. And then you have to copy the values from the old one to the new one over here by looping through using a for loop. But an easier way would be to use the resize function here, which comes off the array class. So you just access this static method, you use the keyword ref, and then the existing array variable name, which is up here. So you can see it's fruits, and then you specify what you want that to increase to. So as you can see here, we had 1, 2, 3 elements in here, but we want to now increase that to 4. So then we can access the third index here and then add the value orange. And and then here we can then print the value. So what we can do is we can delete this code and instead just use that, which is much simpler. And if I run this program, and as you can see over here, for the second element I get the result mango, and for the third element over here I get the result orange. So rather than using this code over here, you can actually just replace it with one line over here to do the resizing, including copying the old values from the old array and then actually changing the reference to the new elements without having to change the array name. So this lets you keep the existing array name, whereas this one you have to change the array name. So as you know, arrays are really fast and they are more preferred than using a list, a generic list, because arrays will always outperform an array list. So arrays are great when you want speed and efficiency and still some flexibility. But of course, in certain situations, array lists are better option as they provide a lot of flexibility, while arrays do not provide that flexibility, but they are very, very efficient. And this is how you declare them. And then you can use the indexing method to access the elements or change the elements like we do here, which is we change the third element to orange. Let us understand the default values for arrays. So here, as you can see, I have declared an array with a size of 3. So it will have 3 elements in it. Now I'm going to look at the element at position 1. What do you think will be the default value for an integer at that position for an array? So if I run this program, what you will find is that the array returns 0 at this position, because by default, whenever you declare integers, the default value for integers is 0. Now we have another example, but this time notice that the data type is string. What do you think is going to happen now? Is the value at position 1 going to return 0, an empty string, or null? So if I run this program here, and let's find out what we get. So as you can see, this was our first value because the default for an integer is 0, but here we are getting nothing back. There is something there, but we don't know what it is. So how do we check this? So here what you can do is you can check it with a null. So is the value in the element that we selected, is that equal to null? So let's find out by running this program. And as you can see, the value here is true because the value in here at the first element is equal to null. So the default value for strings is null. You can also use the null coalescing operator here. And what this does is, if the element on the left-hand side is null, then it will return whatever is on the right-hand side. But if the element is not null on this side, it will return this side and ignore this side. So this is a quick shorthand, and it's known as the null coalescing operator. So it's always going to return stuff on left if it is not null, but if it is null, then it's going to return this side. So if I run this program, so as you can see here, it's null here if the element here is null, and you can see it's printed it's null over here. Now let's take a look at this example. Here we are declaring an array of the following values, and then we are declaring another array, and we are copying the values from the first one over to the second one. What do you think will happen when I set D, which is the second array, to be, and the first element at position 0 equal to 100? What do you think will happen to the one at C when I print it? So at C, this element, do you think it will change because I've changed this one in the second variable, or do you think it will stay the same? So let's have a look. So if I run this program, and as you can see, the element for C, that's the first array, has changed to 100, even though we changed the element for D at 0. This is because arrays, when you do this, when you say D is equal to C, it just copies the reference or the address of the location where the variable values exist. So all this is doing is copying the address, even though it's referring to a different variable name. And then when you modify it and then you try and print the result of the first one, then you get the output of 100. Let's go through different ways of copying an array. So here I have an original array of type int, and it has the following values in it. One way to do it is by using a reference copy, which is again, you declare the array to be the same type as the original, and then give it a name, which has to be different than the original name. And then just over here, point what is equal to, so the new variable name is equal to the original, which is up here. And how I would think of this as is, imagine you have a toy box, and in the toy box, you put a toy in, and then your friend comes and accesses the same toy, and then you put another toy in. Again, your friend puts the hand in, and they find the same toy that you put in. Now, let's say you take out a toy, so you remove this toy over here. If you remove this toy over here, then when your friend puts in his hand, he won't find that toy there. And this is how I would think as reference types. Reference types are like a toy box that is shared between two friends. Both of them can see what's in it or what's not in it. But now imagine you want actually two separate toy boxes. Now you have your box here and then another box here. So you have one toy in here, two toys in here, but your friend has only one toy in his box, or he may have three toys in his box. And notice when he adds a third toy in his box, it doesn't appear in your box. So your toys are different to your friend's. So when you put your hand in your friend's toy box, you'll find there are three toys. When your friend puts his hand in your toy box, he'll find that there are only two toys and they are not the same. So that's what is known as deep copy. So this is one way to do it, is basically you declare your variable chain, same as before, and then you set its length to be that of the original, which is 1, 2, 3 elements in here. And then what you do is, using the array class, you use the static method, that is method that is always available, and you give it the original array name, then the new array name, and then the length. Of course, this is interesting because you could give it a length that is less than the original, so it'll only copy, for example, 2 elements for you. And another way to create a physical copy is by using the clone method here. So again, you just declare your variable as it is, and then you convert your original array over here and clone it. And then the last method using LINQ. So here, what you do is again, declare your variable date type and name, and then do original.toArray. And this is one of the simplest methods of copying an array. Basically, you don't have to remember the complex syntax here. You can just use original.toArray and that would make a copy. So the LINQ method is the easiest method. So if I run this program now, this is the original value, which is 99, and the reference value is 99. This is because, although it's 1 in here, but what happens is I change the original value here. That's why for the reference copy, you see 99. Now notice I take all the other deep copies or hard copies before I change the value to 99. So what it does is it keeps the original values for those because they are deep copies. And that's why you can see for rest of them, it keeps the same value as it originally had. But of course, if we change the original value here, the only one that's affected is the reference type, because reference type, like I said, is one toy box being shared by two friends. So I hope this makes sense in terms of taking copies of the array and the difference between a reference copy and a deep copy. The easiest way to understand the LINQ function where in C# is by simply thinking of it as returning true and false. So let me explain to you how this actually works. So here, as you can see, I am creating a list, and this list will hold a person class. You can see a person class has the following properties. It has name, town, and country. You can see here what we are doing is we are adding an item to our list here, and we are creating a person class. And for the person class, each instance that we create, we are assigning a name, we are assigning a town and a country. How do we filter this so that we only get records which are either London or the country is Spain? So how do we filter these in C#? This is where the where function comes in really, really handy. So here I said you can think of it as returning true and false. And you can see here, this is a Lambda expression. This is basically going to pass in P. What is P, you might say? P is basically each person in our list. So you can see here, this is a people list. So here, that's where we create the people list. And within that, there are 4 people. So what we do is for each person, we say, is the town equal to London, or is the country equal to Spain? So we're checking this is an or condition over here. So either London or Spain, both of them are fine. And as you can see from the data we have only one person that is London, and we only have one person to Spain. This expression here, this is known as a Lambda expression, just returns true or false. How I think of it is, think of it as like a function. You can do it this way as well. So the where function can take in function that basically returns true or false. And this expression over here, that's all it's doing. So if we have a look at if from London or Spain function, you can see it takes in a person class. This is very similar to the Lambda expression. It takes in a P, and then you're checking the properties within here. And if you look at the function over here, that's what we're doing. It's returning if the town is London or the country is Spain. And notice how this here basically returns true or false. And in effect, just returning true or false, which gets passed here. So for each item within the people list, is going to run that function over here. It's going to check if it's London or Spain and then return a true or false. If it's true, then basically that person will be kept. So it will be true here. This will be kept. True over here, it'll be kept. But the ones here are false and false. So those would not get included by the where function and then get filtered out. So that is why or how the where function works. Just think of it as returning true or false course, storing the filtered list in this variable over here, or you could do it using the Lambda expression. And then I'm just going to output the records, and you can see here, Ali over here is London. So that's why this matches this criteria. So that returns it true. And then you can see here, Jamie for Spain is selected because his country is Spain, even though the town is Madrid. But since again, it's the OR condition over here, this record gets selected. And that's all this where function, which is an extension of the LINQ language within C#. That's all it's doing, the different methods of doing the same thing. So let's have a look at this where function. It's part of the LINQ feature within C#, and all it does is filter out your objects, classes, or data that meet a certain criteria. And what the where function expects is it expects something to return true or false per piece of data that it is processing. So one of the first syntax is by using Lambda expressions. So as you can see here, Lambda expression is pretty plain. You can see that it uses a criteria that we want to filter on right within this expression. And you can see there are only two parentheses. These belong to the function where. Next, let's have a look at the other syntax, which is we create a function and we call that function. So here, the where is getting a function. This function is defined down here. So here's a function. It takes in a person class, and then it carries out some logic, and this returns a true or a false based on the logic we have defined here. Another way is using the delegate keyword. So here, basically what's happening is rather than naming our function, we are using an anonymous function. So this means that it takes in a person class and returns true or false by the logic that we have used here. So as you can see, the syntax is slightly different, but it uses these curly braces here, and notice the parentheses here. These belong to the function where, and then with using the delegate keyword, this is mandatory, and then that takes in an argument of person. So this syntax over here looks very similar to defining our function, because if you look at our function, we are using the curly braces and we are passing an argument here. So here we have actually named our function and we can reuse it. But with a delegate, of course, the function doesn't have a name. It just has the keyword delegate. So that's another way of using it with the where clause. And the last way you could do it is by using the block syntax for the Lambda expression. So you can see here that I am using the curly braces here, and we are passing the P object, which basically is the people variable, but we're just passing one instance at a time of the person class. So you can see here the code is basically doing a write line and then just returning is the town equal to London. So this syntax is pretty much the Lambda expression over here, except it is spread over multiple lines. So these are the 4 different ways that you can actually work with the where clause using different syntax. You have probably seen the Lambda operator in C# and have always wondered how did we get here. So let's have a look and understand the basis of Lambda operator. Where did it come from? So Lambda came from a mathematical concept called calculus, and this is what it appeared as. So in Lambda calculus, you'd write a Lambda character and then the letter X and then a dot, and then you would say X plus 1. So what this basically means, this is a function that takes X and returns X plus 1. So this concept is coming from calculus in mathematics, and you probably have heard of functions in mathematics. And then in different languages, C# decided to implement it with this syntax, which is X. It has with the Lambda operator here, X plus 1. In JavaScript, this is how it's done. In Python, you use X colon and then X plus 1. And then in Haskell and in Lisp, you can see the various syntax here. So C# got the Lambda operator from functional programming languages. And when did it arrive in C#? So it was in C# 3.0 in 2007. This came along with the LINQ, LINQ. And before that, you had to use delegates. So why is it so useful? Basically, the advantage is you do less typing. So you can write your function in line. It's more readable as you get used to it. So this is how it evolved. First, when you had to use the LINQ method, you could actually use a full method here. So here we're defining the method is adult, takes in a person class, and then returns the person's age. But then Microsoft changed that and said, why don't we use anonymous functions, which is a function that doesn't have a name. So they used the keyword delegate and passed it a person class and then did some checks, and that was known as anonymous function. function. And even shorter syntax was Lambda operator. So you supply an object like the person here, but without naming the class, you just specify the argument. So here we've got the P, and then that gets passed over here, and then you do your checks over here, and then the output is passed out to the where function. So that's why in your code here today, you see the Lambda operator, and I just wanted to share with you where it came from. It basically came from calculus. This is how it was written in mathematics, and then C#, of course, wanted to use the Lambda operator, and you can see how JavaScript implemented it, and so did Python. In C# you can combine LINQ query methods. So here you can see I am using a where method here, and what this does is it takes in the parameter P, and you might be wondering what P is. P is the person class that we create here. So you can see we're doing people, which is a variable name here, and since this is a list, we are passing in each instance. So you can see I've got different people here, so each of them gets passed here as P. You can use anything here. So basically I've coded P because that's the preferred for the standard way of naming your variables as part of a Lambda expression. So here this is the Lambda operator, and we are passing it down, and what we are doing is once we get that P, we are then saying is key town equal to London, or is the country equal to Spain. If it is, then basically that return this part over here returns true. So it will either return true or false. Then the next LINQ query method is executed, which is ordered by descending. And then again, notice here we are getting the P, and we've got the Lambda operator. P is basically again the same person. So each instance of the item person here, which is a list, gets passed over here again, and then the Lambda operator is used. Lambda operator is basically a shorthand for writing a function, and here we get the name. And since this is ordered by descending, what it will do is whoever meets the criteria of London and Spain, which is basically the first two instances here of the person class, these two would get passed here. And since it's descending, Jamie would appear first and then Ali. Now, to do ascending order, there is no, so if you're thinking about SQL and you might write ascending or descending as such, this doesn't work in C#. You actually have to use the correct method. So here you can see if I do order by, and if I do that, you've got two options here, which is either use order by here, which is ascending, or you can use order by descending over here. So by using order by, it will use ascending for the name, but if you want descending, then you have to do the descending method over here, and then this will sort it in descending order. So if I run this code over here just to print out the names, and you can see it's sorted, printed out Jamie first and then Ali, because we have used the descending method here. So this is how you combine your LINQ query methods. I just keep on adding in the dot operator over here and the next method name. There is something really important I want to explain about the where LINQ method. So as you can see here, this LINQ method actually returns something called the IEnumerable. And what you need to notice is the IEnumerable is a generic interface. So it's a bit like class, but an interface is to say the steering wheel on a car, for example, is an interface. Every car has a steering wheel. You know how to use it in one car, you know how to use it in other cars. It's the same steering wheel. So here, for example, IEnumerable is the interface, so it has a steering wheel. But of course, we know each car is different. For example, a BMW will have a different steering wheel. An Audi will have a different steering wheel. But in this instance, we're using a person class. So why does the where here return IEnumerable? Why do they not return list, which is the original variable data type? So here you can see people data type is declared as a list. So why do they return IEnumerable versus a list? This is the way LINQ works. So what Microsoft have done is, imagine a scenario, you're at a restaurant and there is a large dessert menu. And just imagine your wife orders all the desserts from the waiter. The waiter has to go and make all those desserts, which takes time, and then he has to carry them all with him, your table, and then he has to find a space on your table to put those desserts. And your wife is probably going to get overwhelmed because it's too much information to absorb. So what if you had a scenario where the waiter would go into the kitchen, get a dessert, show it to your wife, and if she likes it, she can eat it, or move on to the next one and say, I don't like it, give me another one. The waiter goes back in and comes out with a new dessert. What happens is she doesn't have to wait for all 30 desserts to be made. She only has to wait for one dessert to be made, and she can accept it or reject it. So that's why when you run the where method, which is available in C#, it won't give you the original list back. It'll give you IE IEnumerable. This is because it wants to give you one desert at a time rather than giving you all of the deserts. So it doesn't have to work out all the data that you have and process it at once. It only has to go and find the first one that matches the criteria that you have specified. And as soon as the match is found, it then outputs that information to you. And how it does it is it does it via the for each. So just imagine, again, your wife at the restaurant, she goes, I want all the desserts. And if you have IEnumerable waiter, they would go and find the first dessert that, for example, doesn't contain nuts and bring that back to her. And then she will say, oh, actually, I don't like that. Give me the next one. Then it will go in again, pick the next one. So the advantage that you have is you don't have to make all the desserts at once. It's one by one to get immediate results. And it's a bit like your Google search engine as well. Out of the millions of pages, you don't get them all at once. You get some results at a time. And as you click onto the next page, the next results appear. So think of IEnumerable as lazy or one by one output of information rather than everything. So that is why the where method in LINQ returns IEnumerable rather than the original list, because if they return the original list, the processing required for that might be very large depending on how big your objects are or how many there are, and it would slow down the processing. So that's why you get IEnumerable rather than list. But notice it does continue to maintain the original properties that you have of your class object that you define.